Hello, boys and girls. Welcome to Science and Daily Life. I am Sir Zamin.
And I am Miss Riemann.
I'm quite sure you're looking forward for today's class as we continue exploring soils. Miss Riemann?
Now, boys and girls, can you recall the last class what we did? We talked about soil. We defined what is meant by the term soil. We also talked about or examined a soil profile. And we talked about the organic and inorganic components of soil. Today, boys and girls, we will continue on that aspect of soil. Now, boys and girls, another component found in soil is called air. I'm pretty sure around you, you've known what is air. We have air all around us. Now, how do we actually prove or do we know that air is actually found in soil? I urge you, boys and girls, let us take some time and we can take some soil and we add some water into that soil. Have you ever noticed, boys and girls, little bubbles coming from that little mixture you made? Now, those bubbles are actually air that is found in soil. Now,
basically what the water actually does is go down and replace the air, pushing the air out of the soil so it bubbles down, right?
Yes. Okay, boys and girls, let us move on today with the types of soil. Do you think there are different types of soil? Why would we say there are types of soil? Let us dive right into that as well. Now, basically, there are three types of soil. You have 1, sand, 2, silt, and 3, clay. These are so classified because they're of their particle size or texture.
So, boys and girls, the texture of the soil can be felt by rubbing the particles between your fingers. Sand has the largest particles, while clay has the smallest. Silt particles are smaller than sand, but larger than clay. A mixture of particles of different sizes form what is called loam soil.
Now, boys and girls, can you take a look at what we're going to do? We're going to actually feel the different particles of each type of soil. Here you can see, boys and girls, I have sand in my hand and I can feel the particle and the texture between my fingers. Sir, can you feel the particle and the texture of loam?
Sure. As it rightfully said there, a loam is a mixture of particle sizes. As we can see, or as I can feel rather, I can feel some small particles as well as some large particles, whereby Miss just felt a lot of fine particles.
Very good. Now, boys and girls, soils can be compared using the following properties. Like Sir would have said, particle size, capillarity, or the ability to draw up water, humus content, texture, air content, or permeability or ability to drain. Now, boys and girls, what is meant by the term capillarity? Capillarity is observed when you put tubes into a container of liquid and water to understand how that movement of water occurs. Here are some activities that will help you in comparing soil. We will start with our capillarity test.
So, boys and girls, what is capillarity? It is the upward movement of water. Now, with sand, loam, and clay, because of their particle size, they will have different capillarity among them. So, give us a minute. Let's go quickly and grab our lab coat. Be right back.
A few moments later.
Now, welcome back, boys and girls. You can see we're fully dressed for our activity here with capillarity. And we'll first start off with our loam soil. We also have here our sandy soil and our clay soil. So we're going to try to compare the capillarity between the three of them.
So, boys and girls, what Miss Raman and myself did, we would have put a little piece of cotton wool at the bottom of the straw to prevent the soil particles from escaping. and we would have put about 10 centimeters of soil into each straw. So all I'm going to do now is place them into the colored solution to see how much of the solution would actually be taken up. So put it all in at the same time. So I have my loam, my sand, and my clay. We're going to give it maybe a minute or so you can actually see and compare the capillarity among the three.
1 minute later.
Okay. Can you help me with that one, miss? Thank you.
Yes.
So boys and girls, pay keen attention to where the liquid is. Let us look at loom first. At loom, you can see it's risen up to this point. Up to this point, it's risen. For sand, you can see it almost went all the way up. And let's look at clay. Clay had the least capillarity action. Let's go back one more time. Loom, sand, and clay. Okay, boys and girls, let us now conclude our experiment on capillarity. We can vividly see in Miss Riemann's hand, she has sand, and the capillarity is very low. In the middle here, I have loom, and the capillarity is in between. But for clay, the capillarity is very high. So when we move on to talk about the comparison of soil type, when we talk about the particle size, you will see how this contributes to the difference among capillarity here.
Now, boys and girls, let us talk a little bit more about permeability. What is meant by the term permeability, or to be permeable? Simply means the ability to drain. What we're going to do for you now is that we're going to carry out a test to show which soil would have the ability to drain more than the other. Take a look at that.
So boys and girls, permeability is the opposite of capillarity, whereby capillarity is the upward movement of water, permeability would be the downward movement of water. So we're just going to be comparing the permeability of sand and clay. Ms. Riemann would have already assembled her apparatus.
Now here you can see we have, you have your funnel, your measuring cylinder, your beaker with soil, we have clay and sand, and we're going to actually filter this through to see which one of these would actually drain the most water.
So we're going to use equal amount of soil sample. So Miss start here with sand to pour it in.
In here you can see we have the sand, and we have 25 ml of water, and we're going to pour this 25 ml of water into the sand.
Students, you observe. In the meantime, I'm just going to pull out another 25 ml so we can compare with the clay. Great.
And here we're going to pour the clay. And we're going to pour 25 ml of water into the clay soil. And here we have the sand and the clay. Boys and girls, can you assume what might happen? Do you think the water will pass through the sand more than the clay, or the clay more than the sand? What do you think will happen?
Now to speed up this a bit faster, we're going to add 25 ml more in each, all right? Let's add 25 ml more. Great.
And we're pouring it into the soil.
Yeah, that speed up the reaction there a bit. Then all we put 50 cm
50 ml of water
or 50 cm cubic of water.
into our soil sample.
All right, so yeah, so sometimes when you're conducting experiments, you can actually alter it a bit so we can speed up the process. But you always have to ensure you have what we call a constant variable. So we put 50 ml in both, all right? Now it's time to read off, Miss Freeman.
Very well. Now, for the sand, we have 23 ml of water.
And for the clay, we have 18 ml of water.
So with that, boys and girls, which one do you think drains or drain more water? We can simply say the sand indeed drain more water than that of the clay. So which one is more permeable? The sand is more permeable. Now we have been talking about the different types of soil. And what we will do now is that we're going to compare each type of soil by looking at the different particle size or the air, permeability, the capillary action is happening there. So we're going to go right into that and talk about the comparison of each type of soil. Now let us start with particle size. For sand, the particle size is very large, whereas for loam, it is mixed, and for clay, it is very small. What about capillarity? It is very low in sand. It is a fair amount in loam, which we saw. And for clay, it is very high. What about humus? Humus, there is none or maybe little in sand. There's a fair amount in loam, and there is high or heavy amount in clay. Have you ever played with boys and girls with sand or maybe loam and notice there is not as much twigs or leaves in your sand with compared to your loam? This is what we're talking about in terms of humus. You can find a little to none in sand, whereas you can find a lot in loam. Let's talk about texture, sir.
Sure, miss. Moving on, we have texture. In sand, the texture is light. Loam, it's medium, but in clay, it is heavy. The air content in sand is very high. Loam, it's a fair amount, but in clay, it is low. And permeability, with what we would have just experienced, in sand, permeability is very high. In loam, it's a fair amount, and in clay, it's very low.
Now, boys and girls, what we have for you today is a nice little poem that we're going to share with you. I am a plant's best friend.
I wonder what plants would do without me to support them.
I hear the sound of the rain as it pitter-patters on top of me.
I see the roots as a plant grows through me.
I want to be seen as something other than dirt.
I am a plant's best friend.
I understand that I am important to the earth.
I say humans need me more than they know.
I dream about not being called dirt.
I try to soak up the right amount of water.
And I hope people will take care of me.
I am plant's best friend.
Now, boys and girls, you should be plant's best friend. Do not do anything that would harm our earth. That includes causing damage to our soil.
And I do hope the poem would have appealed to you to see the importance of soil to the plant.
Now, I trust the poem had made you appreciate soil even more. I want you to join us for our next lesson as we enlighten you on how to improve soil. I am Miss Freeman.
And I am Sir Zamin.
Bye-bye.